This video is sponsored by our good friends at PCBWay, the makers of high-quality PCBs, 3D printing, CNC, injection molding, and more. Hello, Randy Rain here, and welcome to part 2 of me making my own little toy robot from scratch. But don't worry if you missed part 1, I'll fill you in. This is
Randy Robot Garage.
So here it is. This is the robot. It's called the Pixis robot. I'll explain the name later. But let me explain how I got to this point here. So it started off with me having these little tiny motors and me setting rules to make a little robot using these motors. I gave myself a time limit. I was going to use some gears and whatnot. And my first idea was to have tank treads because I like tank treads. But tank treads aren't easy. So let me explain. Here's a little toy tank right here that has tank treads on it. If you'll look, you'll see that it has this ridge running down the center of the track. And it has these little slots in it cut. And this ridge fits into the slots of the wheels. And the notches are cut out so it can travel around the wheel itself. And that's because when the tank turns and one goes this direction, one goes the other direction, there's these sideways forces that get pushed on it, and it will pull the tread right off if you don't have something like that. So I started with something like that. And I had that little ridge. It was more of a V-shaped, but it was still the ridge. And I had the little notches cut out so it would travel around. But the problem was it only worked at high speeds. I could get the thing to go forward and backwards and turn and everything at super high speeds. But as soon as I slowed the motor down to where it would go the speed I wanted it to go, then it wouldn't be able to turn. And the motors would just bog down and just stop. So I played around with different rubbers. A softer rubber, well, that just made it stretchy enough to be pulled off of there. And I tried different shapes of the track. And I took the ridge away completely and made like a flat belt. And even made it convex and everything. But it's still, as soon as you tried to turn, the forces going sideways just popped them right off. So the solution was simple. It needed to be redesigned. It needed a lot more gears. So I had to start over, and that's what I did. But when I started over, I just decided to ditch the tank treads. I decided to go with the double wheel system, and I'm glad I did, because I added one more gear, and it still wouldn't have been enough for the tank treads. You would still need at least 2 more after that to get the motor going fast enough to gear it all the way down, to get enough torque, to slow it all down so it could actually move and use the big V belts that would stay on there. Which brings me to a saying that I created. It's called, "Don't bite off more than your attention span can chew." And I knew how much R&D it was going to take for those tank treads, and that was going to go way past my time to build this robot that I gave myself. So how does the robot work now? Well, there's 2 motors in there for each wheel. It has a gear. It goes to a bigger gear, which has a smaller gear. It's a compound gear. It goes to another compound gear. It goes to another compound gear, which finally goes to a gear that turns the shaft, which turns the wheels. And then the brains of the whole thing is the PYXIS chip. The sensory inputs are the 3 infrared sensors on the bottom. These are very close range sensors. They're used for edge detection and for it to know if it's on the ground or not. Then it has another infrared sensor, detects a little bit far away, and that's for object detection. It has several LiPo batteries in it, and it's completely rechargeable with this little charging circuit. So that gets you caught up on what it is, but there's one more piece that I didn't show last time, and that's this outer shell. And the shell was created by the sponsor of this video, PCBWay, who are the makers of high-quality 3D printing, PCBs, injection molding, CNC, and among other things. And I'm no salesperson. If I was a salesperson, I'd be out selling things, and I wouldn't be making these videos. So all I can tell you is I had them 3D print this for me, and I'm blown away. I am completely blown away at the quality that I have here. I mean, my printer, this looks like a turd on a stick compared to what it looks like. I am just completely blown away, and it totally amazes me I wish I had their 3D printer. That's just crazy. So I was talking to my good friend Bizarro about this. He's a maker and creator as well. And he was saying that it's best to have these printed out because of the amount of prep work and the amount of post-curing and all this stuff. And he's probably right, because this is like, I think it was like $12 or something. I don't remember. Anyway, PCBWay, they make great PCBs, great 3D printing, and I'm sure there are other stuff that I haven't tried yet, which I want to, is just as equally as impressive. So go check them out. They're friends of the maker community. PCBWay. It's all going to have to be painted black on the inside because when I turn it on, which I'm going to make a little key that you have to turn it on with. So, but right now you just push that. Now you can see it lit up here, which means it's detecting something. So, of course, it's going to go backwards. So it's reflecting that infrared back in there from this thing. So all that inside has to be black. And I'm just going to paint the whole thing black as a primer first. But I'm also going to sand all this. Even though it's freaking nice, it's still my low poly model that needs to be fixed. So with the heat, I think it's pretty baked on there. I'll give it a little steel wool action. Well, I had some crackling, and that's just gonna, there's some here too, not as bad. But that's just the way it's gonna have to be. And so I printed these decals on this transparent, this clear, translucent type stuff, the sticker. And I have some of this duct tape peel and stick laminate that's going to go on top. Now I'm going to peel this off. And I have tin foil. Now I'm using the 3M Super 77. You don't want it to be too wet. So people have asked me before why I don't use these ICs to control the motors. Well, the reason is because on everything, the electronics, the mold making, the building, the engineering, everything, I'm all self-taught, 100% self-taught. And the reason I didn't use these, didn't know how. Well, guess what happened when I needed to try to make this little robot? And my little circuits didn't work when I miniaturized them. So I went with this, and so I learned, and I'm happy I did. So I'm going to show you how they work. So these are 16-pin integrated circuits. I'll tell you which pin does what. This pin, this pin, this pin, that pin, that's all negative. And really, this negative is for these here, this negative is for these, this negative is for these, this negative is for these. But you just ground the whole thing out, really, I guess. And then this pin is positive for the circuit, for this IC. So should be 3 to 5 volts. This is not the positive that turns the motors. It's the positive that runs the chip. The positive that runs the motors is down here. And this can actually be up to 60 volts, I think. And then these pins here, these two, and these two, these are going to the motor. So here's the motor, pin here, there. Same thing on this side. Motor here, pin here. These are input pins here. And these will operate just like you would be putting electricity onto the motor. So if you put a positive here, you put a positive here, that would be like putting a positive here and a positive here, which does absolutely nothing. If you put a negative here and a negative here, that would be like putting negatives here, which would do nothing. But if you put a positive here and a negative here, the motor will turn one way. If you put a positive here and negative here, it'll turn the other way. So it's the exact same as running the motor, but in this way, you're putting 3 volts, 3 to 5 volts onto here, even through a resistor, and you could get up to 60 volts to turn the motor. And it's run through a rectifier so that the electricity only turns one way. It doesn't go back through the circuit. But you also, right here, over the motor, you still need to put a capacitor. I think I put a 0.1 microfarad capacitor, something like that. Just a small one across the motor. You have to. Now that only leaves these 2 pins. And what these do are the control. So you could have positive, negative, negative, positive, however you want it up here. But if you put nothing onto this pin, the motor would not turn. Only till you put a positive volt here will the motor turn. So this is like the switch. And the cool thing is you can actually pulse this right here. So you could pulse it. And you can adjust the speed like that. So if there's more positive than negative pulses, it's going to go faster. The more negatives you add into it, the slower it goes. And that's the same thing up here, is you can put these pulses in. And that will control the speed of the motor, but there is a little trickiness to it, and I'll get to that. But that's how this works. And so now it's down to the brains of the thing, and I just use PYXIS chips. And people ask me why I use these PYXIS chips. Well, there's lots of reasons. One is they're pretty powerful. They can do a lot of stuff, and I'm not doing majorly difficult things here. I don't need much. They're also not a big circuit. They're just a little chip. This one's a 14 pin, but I also use the 8 pin a lot of times. And they're really cheap, which is nice. And they use the basic language. And if you're like me, whose first computer was this 8-bit toy computer, basically, well, you had to know basic language. That was the first thing you learned. And so you just program these with the basic language. And I'm pretty sure there is a pulse out on there, but I'm not sure if the pulse out takes over the whole operation of the chip. So I just did the pulsings that I needed for the motors in the code itself. And then here's where I learned something new about the PYXIS chip. It starts at 4 megahertz. That's the default. And I didn't know you could change that. But when I started pulsing the motor on the 4 megahertz, you could see the pulse in the movement of the robot. It would go tuk, 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 like that as it moved forward. And then I alternated the pulsing of each motor, and it did this wobble, 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 which was kind of cute, actually. And I thought about keeping that and making it look like a little chicken and call it like the chick bot, and it just went wobble, wobble, wobble. But I learned you could change the speed of the chip. You can make it 8, 16, even 32. So when I changed it to 32, the wobble was gone and it was completely undetectable, and it just ran smoothly, and I could control the speed perfectly. If you look at the bottom, it has these little infrared sensors, and those are to detect the edges. Now, it started off meant to detect the edge of a table, in which it does. It will detect the edge of a table. And when it was tank tracks, it could have saved itself from falling off the table, but here, not so much. And the reason is because with the two wheels, I mean, this is exaggerated, but when it goes forward, it's leaning back. So it's forward, and then when it goes backwards, it's going to go this way. I mean, of course, that's exaggerated, but that's how it goes. And if you look at the sensors, they're just in front of the wheels. So if it was going straight and it came and both sensors went off the edge, it would stop. But then it needs to go backwards. And as soon as it does, all the weight shifts forward. Even though the wheels are trying to make it go backwards, the weight shift just pushes it over the edge. So I had a feeling that was going to be the case. So basically now the edge is the black border of its play mat. And that brings to the problem of the timing. So what it does is it goes until it hits the edge. It detects an edge, it backs up until it no longer detects the edge. And then depending on which sensor was triggered is depending on which direction it's going to rotate. So then once it rotates, there's no sensor detecting how much it rotates. There's no gyro on it going, oh, I rotated 30 degrees. So it just has to be a timing thing. So it has to spin for a certain amount of time until it's no longer in the position it was, and then start moving. The internal timer counts by seconds. I could at least get down to 1 second. So that's what it does. When it detects an edge, it backs up to it no longer detects an edge. It rotates for 1 second, and however much it turns in that 1 second, that's the direction it's going to go. And same goes with the object detection too. So as soon as it detects an object, it backs up until it no longer detects an object, then it rotates for 1 second, and then it goes in that direction. There's more redesigning that needs to be done. I mean, the switch here is not a good idea. You have to push it in to get the shell on. You have to push it in to get the shell off. To turn it on and off, you have to use this little key that I made. It does say Pixis on there, though. And you can turn it on and push it. I don't really mind all that much, but it could go on the top up here. And so that wouldn't inhibit the shell. It could slide straight down on top of it. I poured some new tires. Oh, it has some brand new, nice white tires. So why is it called the Pixis robot? Basically came down to a little box. And what is a little box? Well, I looked it up in a thesaurus, and a Pixis is a little box. It's actually a little box that they used to keep toiletries in, but now, since no one carries a Pixis anymore, and it's just a little box. It's also a name of a constellation. But it's such a cool little name and perfect for a little robot. So that's pretty much it. So you ready to see it in action? It's all charged up. I have some cups here that I've been using. I put them like this because it does have, bad peripheral vision. So if you put them like this, where the skinny side's up, it doesn't detect it before it hits it down here. But if you put them this way, most of the time, it still clips some cups every now and then, but that's okay. They're cups. But we can make a little maze. I programmed a little mind of its own in there too. So sometimes it just stops and then goes. Sometimes it stops and turns around and then goes. Sometimes it turns around and then stops. And then sometimes it just turns. So there it is, my version of a toy robot, the Pixis robot. If you enjoyed this, I sure would appreciate a big thumbs up. You know how that helps the whole YouTube thing. And if you want to see more stuff like this, hit the subscribe button. I want to thank these people right here. These are patrons. These are people helping me out. These are people who brought you the Pixis robot. And I want to thank them oh so very much. Of course, there is a link below if you would like to become a patron, and there are some perks. I'd also like to thank PCBWay for sponsoring this video, and they do have some nice products. There's proof right there. Anyway, thanks for watching. That was
Randy Robot Garage.
So if it was going straight and it came to the edge and both sensors were off, Jesus.